Hello guys, and welcome to this Meg segment. I'm your host, Zachary Anderson, and today we're going to be taking a look at electromagnetism. What is it? How does it work? What is equilibrium? I'm really excited to share these things with you, so let's dive into it. One of my favorite rides in the whole world is the Meg train in Japan. Now this train is able to travel really fast. It's one of the fastest trains in the world. But how does it do this? Well, one reason that it's so fast is because it's got almost zero friction. And that's because the train is actually levitating slightly above the track. Well, how does it levitate? That's mind-blowing. We can levitate? Why are we not doing this all the time? Well, the answer is yes. And for the first question. And the second is, well, it's a little bit more complicated than just, randomly levitating anywhere. There are some special conditions. So I'm gonna take you guys into a demonstration of how we can actually make something levitate. And then I'm gonna explain how this levitation really works. So let's take a look right here at this crazy contraption that we built. Mad scientist. So you can see here, we've got a whole bunch of crazy components. So this is our battery pack. These are some electronics for controlling our circuit. And then this guy here is actually what we're going to be looking at today, this electromagnet. So what I'm gonna do is I'm gonna take this beautiful ballerina right here, and I'm just gonna hold her and then let go. Oh my gosh. It was unstable. All right, let's try that again. So let's go ahead, let's put this ballerina right here. Almost got it. She's freaking out. There we go. Okay. So it's levitating. Oh my gosh, how does this work? Well, that it has to do with what's known as an equilibrium. Oh, it just fell again. Oh my gosh. All right, let's try that again. Let's get this balancing here. Wow. Ooh. There we go. So the ballerina is able to levitate due to an equilibrium. An equilibrium just means that everything is able to stay at that same state. Equal on both sides is one way that you can think about it. So one way we can think about this ballerina is like a tug of war. So there's a force that's pulling down on this ballerina, and that's the force of gravity, right? That's what makes us feel really heavy. The force that's pulling back up is actually a magnetic force. The same magnetic force that we see here. Wow. So these are two permanent neodymium magnets, the same as in my demonstration. And you can see when I get them really close to each other, let's see here. Oh, look at that. They snap together. Well, that's because on each magnet, there's a positive end, or a north pole, and a negative end, a south pole. And these two sides of our magnet actually attract together. So this is a force that's found in the natural world, but we can actually control this, believe it or not. Now, one way that we could maybe try and control this is, by holding the magnet, lifting it up and down, moving it kind of fast to try and get the ballerina to stay, right? Like I could lift the ballerina up right now if I bring my magnet in there, right? But you can see my magnet's a little bit too strong and it's pulling the ballerina up rather than having it levitate. But you can see at this point here, it's actually strong enough. It overcomes, so let's see here. Let's do a test. So at about here, if I let go, the magnetic force is actually able to overcome gravity and lift the ballerina all the way up to my hand. If I hold it a little bit lower, the ballerina just falls due to gravity. So there are two forces pulling on this ballerina right now. The magnetic force from the magnet that I'm holding and the gravitational force of the Earth. So there's a specific point at which the ballerina will either will actually not be going straight up to the magnet or straight down to the ground. It's actually going to be equal forces pulling up and pulling down. And that's what's known as that equilibrium. But if we're just trying to find that equilibrium ourselves using a permanent magnet And using this ballerina is really, really hard. I don't think this is even possible. One side is always gonna win. It's either gonna be the magnetic field or the gravitational field. Yeah. So, is there a way that we can maybe widen that equilibrium state? Is there a way that we can sort of increase the range at which those two forces cancel out? And it turns out that there is, if we're using closed loop control. So here, what we have is an electromagnet. So an electromagnet is like a permanent magnet that we can turn on and off. So rather than just having it on all the time, this electromagnet actually turns on and off. And that actually widens that range at which we can find our equilibrium. So it actually makes it possible that we can make this ballerina levitate. So how does this work? Well, when the ballerina gets too close, there's a sensor that measures the magnetic field from this magnet on the ballerina. So when she gets too close, it turns the magnet off. When the magnet turns off, the ballerina starts to fall. And when it gets outside of the sensor, outside of the range of the sensor, the magnet turns back on again and pulls the ballerina back up. So it's actually this constant state of turning on and off that actually manages to find that equilibrium. And this is known as it could be known as a PWM signal, right? Pulse width modulation. We're turning something on and off to find a equal state. This is sort of how your ovens work, right? If you have an electric oven, it's actually turning on and off at a specific rate to reach a specific temperature. So that's sort of what's happening here. But what's nice is we've got closed loop control. So what does that mean? Well, closed loop control means that we're not just trying to set a temperature randomly. We're actually taking in what's known as feedback. So we're measuring how close the ballerina is actually to the magnet. There we go, beautiful. So that covers our electromagnetism. I hope you guys found this video interesting. Make sure to check out our programs at zenmakerlab.com. We've got an electronics program that actually uses these same electronics in 3D printing to create cool toys just like this. So make sure you guys check us out. I'm Zachary, and thanks for checking out my video.